Hi everyone. In this video, we are going to look at the order of operations when we evaluate an expression. Also, some application problems in geometry. As you can see here, we have this learning objectives. So after we do some calculations using the order of operations, we are going to look at how to calculate the area and the volume of different shapes. So let's get started. And the very first one, see, we're going to simplify these two expressions. In other words, we are going to do some calculations using order of operations. Look at the first one. Say we have a parentheses, we have multiplication between 8.2 and the parentheses, and then we have a subtraction. So in the order of operations, we always calculate the operations inside the parentheses first. So if I do this calculation, it's going to be 2.75 minus 8.2. Now we're supposed to do this addition first, which will be 7.4, right? 7.4. Now we only have two operations left, minus and multiplication. So we do multiplication first. So 2.75 subtract. So let's do the multiplication first. I get 8.2 times 7.4. Actually, we can do all this whole thing in the calculator in one step, but our goal is to make sure people understand the order of operations. That's why we do it step by step. Oh, we already get that. This is 60.68. So now we do subtraction 2.75 minus 60.68 equals. So we got negative number, negative 57.93. So that's our answer. Now let's look at the second one, B. In this one, we have parentheses, but this parentheses doesn't count because it's about the operations inside the parentheses that we should do first. But in this case, we only have a single number. There's no operations inside. So this doesn't count in terms of the order of operations. So we have exponential operation, we have multiplication, we have division, we have subtraction. Among all of these different operations, the exponential operation should go first. So we are going to do 0.4 square, which is 0.4 times itself, right? So I copy everything else. Zero 0.4 times itself is 0.16. Now you can see we have division, we have multiplication, we have subtraction. Both division and multiplication have higher priority than subtraction. In other words, we can do this two in parallel, then we do subtraction. So let's do that 12.6 divided by 0.2. We turn on the light. Equals, we get 63 exact. So 63 minus 6.5 times 0.16. We get 1.04. So 1.04. Now let's do the subtraction. So we get 63 minus 1.04. Right? Yeah. The answer is 61.96. 61.96. So all we need is to follow the order of operations, and that's all. Now we have another one on this page. So let's look at what operations we have. First, we have brackets, and inside we have parentheses. say all of these parentheses and brackets and braces are called grouping symbols. Grouping symbols. Grouping symbols. They are all the same except they look different. Otherwise, they all serve the same function. That means they group operations together. So whenever you have layers of grouping symbols, you always do the one that inside first, and then do the one that is outside. So in this case, we need to do this addition, then we do division for this whole thing. Then between division and multiplication and square root has higher priority. So let's work out this brackets first. I'm going to do it step by step again. And addition, apparently we get 1.2 plus 0.3, that's 1.5. Then divide by 5 and divide by 2 times square root of 0.09. Now we do brackets first. Brackets is like parentheses. So 1.5 divided by 5, that's 0.3. Now divide by 2 times square root of 0.09. We should do a square root first, which should be 0.3. Let's do it. Square root of 0.09 equals 0.3. So we get a 0.3. Now pay attention to this, this part. Between multiplication and division, there's no priority one over the other one. In other words, you need to do the operation like first come, first serve, from the left to the right. So we do division first, then we do multiplication. 0.3 divided by 2, we get half of it, which is 0.15, then times 0.3. That's going to be 0.045. Let's use calculator. Times 0.3, 0.045. That's our final answer. Now, next one. Sometimes we have expressions that have a mixture of fraction and decimals. That how do we do those problems then? So basically there are 3 of these. We only do the first 2 because if you look at the third one, it says write each decimal number over 1 in fraction form. In other words, for this decimal, you put 1 on the bottom, treat it like fraction. But we don't really do this third method in this video because strictly speaking, a fraction means you have 2 whole numbers, 1 on the top, 1 on the bottom. Usually you don't use a decimal number inside a fraction. So we only do the first 2 methods. So first approach is that you write everything in fractions so that they all become fractions. So let's do that. 2/3 is already a fraction. Now we need to convert this decimal number to a fraction. 6 is whole number part. You have 6, and this is the fractional part. How many decimal digits we have? We have 2. That means 100 on the bottom. That's 2 digits. And we are using decimal system. Each digit represents 10. So 10, another 10, that's 100. So you have 9 on the top. That minus 3/8. Now, when we do multiplication with fractions, we have to convert the mixed number to the improper fraction first before we do multiplication. So let's do that conversion. 2/3. 6 times 100, 600 plus 9. That's 609, and 100 on the bottom minus 3/8. Now, when we multiply fractions, we always try to simplify them first before we actually multiply. So you can see between 2 and 100, we can cancel 2, get 50 on the bottom. Basically, divide both numbers by 2. 2 divided by 2 is 1. 100 divided by 2 is 50. Now, between 3 and 609, 609 can be divided by 3. How do I know that? When you add these digits together, you get 15. 15 can be divided by 3. So this number can be divided by 3. So 3 divided by 3 is 1. 60 divided by 3 is 20. 9 divided by 3 is 3. So we have 203. Now double check with between these two, they cannot be further simplified. So we just have 203 over 50 minus 3/8. Now we need to convert this back to so let's do subtraction before we convert it back to mixed number. Now, since these two have different numbers in the bottom, we need a common denominator between 50 and 8. So how do we find a common denominator? So there are different ways to do that. One way is that you factor each number into prime numbers. This becomes 5 times 10, 10 becomes 5 times 2. So you see all of the three are prime numbers. So this is the 5 squared times 2. This is a factoring of 50. Now we factor 8. 8 is just 3 2s. So 2 times 2 times 2. Now, what is the common denominator? Common denominator will be each of these different factors raised to the highest power. So we only have two different numbers, 5 and 2, right? 5 and 2. So each one raised to the highest power. So highest power for 5 is 2, highest power for 2 is 3. So now we multiply them together. This is 8, and this is 25. 25 times 8 is 200. So 200 is common denominator. So write 50 into 200. That means you have to multiply both sides by 4 because 4 times 50 is 200. This one times 4 is 812. Now 8 has to become 202. Which number times 8 become 200? Basically, you just use 200 divided by 8. You can also look at here. This is 8. You need times 25. So both sides times 25. 3 times 25, 75. Now this is our answer, and we are going to use 812 minus 75. We get 737. Now we need to convert it back to mixed number. So use 737 divided by 200. So I just divided by 200. 3.685. That means I have 3 200s in it. But we need to rewrite that 0.685 into a whole number. So how do we do that? All you need is take the 3 200 away from this one, which is 600. So 737. If you divide it by 200, you're going to have 3 here. That's the whole number part. That's 600, right? The remainder is 137. So 137 over 200. Now, that's our final answer in terms of fraction format. Now, second method says you can write each fraction as decimal. In other words, you can convert all fractions to decimal. You do it as a decimal expression. So we convert 2/3 to decimal. We're going to convert 3/8 to decimal. So let's do that. 2/3, if you use 2 divided by 3, that's 0.666 forever. So let's take 3 decimal digits, 0.667, then times 6.09, then minus 3/8. 3/8 convert to decimal should be 0.375. If we double check, 3 divided by 8, 0.375. Minus 0.375. Now this is easy. We're going to do the whole thing in one step. Multiply and subtract. So 0.667 multiply 6.09 minus 0.375. So everything is good. So we get 3.687. And this two is supposed to be the same, but I round a little bit because I only take 3 decimal digits, but they should be very, very close. So if I try this one, 137 divided by 200, see what do we get? Just curiosity. 685. This is a 687. So that's why this is rounded up. You get a little bit more. But if you round everything to 2 decimal digits, they're going to be the same. 3.69. The other one also 3.69. Now, next topic, we are going to look at how to find the weighted mean. Weighted mean itself is another word for average. So you are looking for the average of a group of numbers. So why we call it weighted means? Sometimes a number appear multiple times. You don't want to add them together one by one. That's too tedious. It's not efficient. Instead, we just multiply the number by how many times the number occurred. So let's look at this particular example. So what is the GPA? Grade point average. Actually, it's a weighted mean, weighted average. So let's look at the definition. It says the sum of the total grade points earned divided by the total number of credit hours. So the result is how many points you get per credit hour. So that's average. Now, let's look at this particular example. This weighted mean method is just a quicker way, more efficient way to calculate the true average. Otherwise, you can still get the same average by adding all of those numbers together, even though they're repeating. Just add them repeatedly. Eventually, you're going to get the same average. But the weighted mean method is just a more efficient way to do it. So in this case, each A was 4 credit points. So 4 points, B plus 3.5, and so on. Now, this is how you calculate GPA, total grade points divided by total number of credit hours. Now we have a student here. This student has all of this grade already. So Math 100 is a 5 credit hour course, and this person got B plus, and the rest are very similar. Just information about this person's grades. Now let's look at how to calculate GPA. For the convenience, I'm going to write all of these credit values on the side of this third column in here. So B plus is 3.5. It was 3.5 points. C plus is 2.5. 2.5. That means each credit hour is worth 3.5 for B plus. Each credit hour is worth 2.5 points for C plus. Now C, 2. C is 2. A is 4. Oh. Now this is what you do. First, you multiply credit hours because it's a 5-hour class, 5-hour course. You multiply this credit hours by this value because each credit hour was 3.5 points. You get 5 of them. That's why you multiply. So I'm going to multiply this using calculator and then put it on the last column. 5 times 3.5. I get 17.5. Now next one is 3 times 2.5. That's 7.5. Now 3 times 2, this is 6. 4 times 4, this is 16. Now this is the credit points from each course, right? To find the total credit points, total grade points, add them all together. So I'm going to add them up. I get 17.5 plus 7.5 plus 6 plus 16. So totally, I get 47 points. This is total credit points, but this 47 points come from all of these 4 courses a total number of credit hours. So we need to add this total number of credit hours together too. So apparently this three give us 10, right? 6 plus 4 is 10, 10 plus 5, 15. Now we are going to calculate our GPA. To calculate the GPA, we are going to use total grade points from that formula, 47 divided by total number of credit hours. So 47 divided by 15. 3.133 repeating. So 3.133, you put a 1 on top of digit repeating, but your people the digit repeating. But if you round it to 2 decimal digits, you're going to have 3.13. That makes sense. You got a couple of C's, you got a B, you got an A, so a little bit over B, that makes sense, right? Okay, the next one, we're going to do some calculation again, but this one is called evaluation of expressions. And what it means is that you're given an expression such as this one. This is from physics, but we don't care where it comes from. We just have an expression. We have some variables in it, right? V, T, A, and T. So we are given the value for these variables. When we evaluate an expression, all we need to do is replace all of these variables with given numbers and do the calculation. So let's plug in. V is 30 and T is 0.4 plus half times A is 12.8. T itself again 0.4. T squared, 0.4 squared. So now we just need to follow the order of operations to do the calculation. Since this multiplication and all of this stuff have higher priority than addition, so we can do either side of addition first. So 30 times 0.4, that's 12. And we do this part, but this part, we have to do the square first. So half, let's do one more step, times 12.8. 0.4 times itself is 0.16. Now I'm going to multiply all of the three together. Half itself is 0.5. So 0.5 times 12.8 times 0.16. Yeah, that's right. Equals 1.024. 1.024. Now all I need is add 12 to this result. So add 12 to it. I get 13.024. So that's final answer. In other words, given these values, this expression is evaluated at this number. If you have a different set of numbers, this expression will give you a different number. Now I have another one. It's just a practice doing all these calculations. Now this is a compound interest formula. Again, we don't care what it is. We just focus on how to do calculation correctly. So this equals 1 plus interest rate R, which is 0.08. N is 4. Now to the power of n times t. N is 4 again. T is 0.5. Now let's simplify it a little bit before we do the calculation. 1 plus 0.08 over 4 to the power of 2. Now at this point, since I teach all of different courses, we don't want to do this division inside parentheses first. Nothing wrong with that. The reason I said that is that this number, when you do division, sometimes give you a decimal number that has countless digits. In other words, you have to round it. When you round it, you generate the rounding error. And that rounding error inside the parentheses also will compound itself. As a result, you get a lot bigger error than it's supposed to have. So that's why we just let the calculator do the whole thing. So I'm gonna do that. Parentheses 1 plus 0.08 over 2, close the parentheses, then to the power of 2 equals. So it's this way, this whole thing doesn't have any rounding error. We just do rounding if required to a certain place. That way we can control the error because we don't know how we know how much the exact answer. We just round it to the desired decimal digits. I just leave it because we don't have requirement to round it to a certain decimal digit. Now the last part of this video, we are going to look at how to solve some geometry problems. So this is the formula given for the area of these 3 different shapes: triangle, trapezoid, and circle. Now let's look at our first example here. We need to find the area of the triangle. So apparently this is the base, this is the height. Area of triangle is half times base times height. Make sure these two are perpendicular. It's not just 2 letters. Even if you get 2 letters with same labels, B and H, if they are not perpendicular, you cannot use this formula. So in this case, half times base, 4.8 times 2.9. So it's half is 0.5 times 4.8 times 2.9. So we get 6.96. Whenever we have some measurement, we want to carry the unit. Area has unit of a square. So this inch, we're going to have square inches. Make sure you have unit because if no unit, if people mistake this as foot, 6.96 square feet versus 6.96 square inches. How much difference between those two? 144 times difference. It's not tiny bit difference, huge difference. Now let's look at another one, the other one. Find this area of trapezoid shown in below in here. So trapezoid area is half times the sum of these 2 parallel sides. So one is called A, one is called B, then times height. Height is the distance between these 2 parallel sides. So this is direct plug in. So half times 4.86 plus 5.34, then times height, which is 9. Make sure they all have the same unit. If they don't have same unit, you have to do the unit conversion first. So I'm going to do this addition first because they are inside the parentheses. 4.86 plus 5.34. I got 10.2. So times 10.2 times 9. Now I can multiply all of the 3 together. 0.5 times 10.2 times 9 equals 45.9. This is the area, the unit is the meter, so we get square meters. So that's it. Now the last one, find the area of the circle shown in this picture. So the area of a circle is pi times radius squared. So apparently this is 5.6. It's not radius, it's called a diameter because it's the whole thing throughout across this circle through the center. Only the distance from center to the edge is called radius. In other words, we need half of this 5.6. So R equals 5.6 divided by 2 to get a half of it, which is 2.8. Now we can use the formula. It says use 3.14 for the pi. Otherwise, you need to use full pi. So 3.14 times 2.8 squared. Now I do this whole thing using the calculator. 3.14 times 2.8 squared equals, oh, that's a lot, digits, 24.62. We take 2 decimal digits, 24.62. When you do your homework, you need to look at the requirement regarding how many decimal digits you should round it to. Here it's not about rounding, it's about how to implement this area formulas. So we just take 2 decimal digits randomly, okay? And this is in centimeters, so centimeter squared. This is the area unit. Now, some volume problems. First, we are looking for the volume in this example 7 of this cylinder. The cylinder volume formula is pi times r square h. R apparently is the radius of this circle base, and the height is the height of the cylinder. So use 3.14 for pi again, 3.14. Radius is given, that's 4.5. But just make sure they all have same unit, times this 3 pi r square times height. Height is 12. Now again, I do the whole thing in one step. 3.14 times 4.5 squared times now I'm going to do this part first, because I'm not sure if that times is after 2 or after 4.5 squared. So let's make this equal to, then I times 12. Just make sure the calculator follow the order of operations. So 763.02, and this is the volume. We're supposed to have volume unit, that's a cube. So that's our answer. Another one, this time the volume of a pyramid. So this is the formula. The volume, this is the formula for the cone. The volume from pyramid is very similar. So the cone, the pyramid is a inscribed figure of a box. Say, if you have inscribed figure of this box, you can see you get pyramid inside. What's the volume formula for pyramid? We know the volume of a box is length times width times height. And the inscribed figure, that's 1/3 of that. It's very similar to this formula. What is the volume of a cone? This cone is inscribed inside this cylinder. Cylinder, the volume is pi r square of h. Pi r square h, we just did that. So it's 1/3 of that. They are very similar in terms of structure. 1/3 times length times width times height. Length, width, height. We're given all of this. So 1/3 times, they happen to be a square. That could be different, okay? 3.5 times 3.5 times 12. So now let's just do that. 1/3 is just this whole thing divided by 3 in the end. I don't want to plug in 0.33. If you want to do that, make sure take more decimal digits, because any rounding error in here, when you convert it to decimal, will be exaggerated by this many times. That's why I only divide by 3 at the end to control the error. 3.5 times 3.5 times 12, then divided by 3 to get 1/3 of it. So that's a beautiful number. I got a whole number, no rounding error. 49 an inch cube, that's the unit. Now, how about the volume of this cone using 3.14 for the pi? And this is the formula. So 1/3 times pi, 3.14 times r square. So what is the r then? And this the actual figure is on the next page. So that's it. That's here. So let's work on this one. Volume equals 1/3 pi times r square h. So 1/3 is 3.14 for the pi. What is r? R is 3.5. What is height? Height is 6. Again, make sure they have same unit. Now, as usual in the what we did in the last example, we're going to do all of this and then divide by 3 to get 1/3 of it. So 3.14 times 3.5 square times, it should be okay, times 6 equals, then divided by 3. 76.93. I'm going to redo this just to double check if this is okay. I'm going to do this one, then get a result, then multiply by 6. So 3.14 times 3.5 square equals, then times 6 equals, yeah, it is right, divided by 3. So 76.93. That's the final answer in centimeter cube. And that's the volume. Now, this one, find the area and the volume of a composite form. So we just have two examples here. One is find the volume of a sphere. So this is a sphere. The sphere, we only have one measurement, that is the radius. This one measurement solely determines the size of the sphere. So it solely determines the volume of this sphere. And the formula for the volume of sphere is 4/3 times pi r cube. And that's all. So 4/3 times using 3.14 for the pi. What is r? R is 0.2 meters cube. So I'm going to multiply all of this on top, 4 times 3.14 times 0.2 cube, then divide by 3. 4 times 3.14 times 0.2 cube. Oh, 0.2 cube. That's wrong. 0.2 cube, then divide by 3. I do all of this in one step. 0.0334. I'll write down this number, 0.033493. Usually, when you have very small numbers, you want to keep more decimal digits because any small rounding error in terms of percentage is huge. So I'm going to take 3 decimal digits, non-zero decimal digits, 0.0335. Yeah, when you do your homework, you want to look at the actual requirement when it comes to rounding. This is meter cube. So now the last one, find the area. Apparently, we don't have a formula for this shape. That's why they call it a composite form. This whole thing, this shape, is composed of 2 different shapes. One is right triangle, one is half circle. So if we can calculate the area of each part, then add them up, we get the total area. That's our strategy. For the triangle, the formula is half times base times height. We learned that before. The requirement is that the base and the height have to be perpendicular. Apparently, these two are perpendicular. So this is what we need. Times base 1.6 times height 0.4. And that's, let's do the calculation. 0.5 times 1.6 times 0.4 equals 0.32. Now let's calculate the area of this half circle. It's very easy because we all know circle area is pi r squared, right? We need half of it, half circle. So half times 3.14 for pi radius. Now be careful, this whole thing is diameter, half of it will be the radius. That's 0.8 square. Now I do all of this in one step, 0.5 times 3.14 times 0.8 squared. Yeah, equals 1.0048. 1.0048. Now the final answer is the total of these two areas. So basically, we just add these two numbers together. Since I already have this number on screen, I just add 0.32 to it. Equals. So we get 1.3248. This is area. Depend on the rounding requirement. When you do your homework, you round it accordingly. But this is the final answer. Yeah, that's all for this video. See you in the next one.